ID, the Future, a podcast about evolution and intelligent design.
Welcome to ID the Future. I'm your host, Andrew McDermott. How much do you know about intelligent design? How would you define the term? And are you prepared to defend intelligent design to friends, family, or associates who may be critical of the idea, or just don't know much about it? Today, Dr. Casey Luskin provides the basics you'll need to confidently discuss and defend intelligent design with others. Dr. Luskin is an attorney, as well as Associate Director and Senior Fellow of the Center for Science and Culture at Discovery Institute. In this recent talk, Luskin shares with us the fruits of decades of experience communicating about and arguing for intelligent design. He explains why the commonly heard definition of intelligent design fails to adequately describe the theory. He reviews all the ways intelligent design reasoning is already being used in science. And then he shows us how to refute the common assertion that intelligent design isn't science by explaining how intelligent design uses the scientific method to detect design. Take notes if you can, and feel free to listen to this brief lecture more than once. Now, here's Dr. Casey Luskin.
This talk is going to talk about how we can defend the theory of intelligent design. What are some common objections that you might encounter, and how to handle objections when they come up that maybe you don't know how to answer. And this talk is going to assume a sort of a very basic level of knowledge about intelligent design. After all, if you're going to defend ID, then I'm going to assume that you probably already know a little something about it. But if you don't know a lot about ID, that's okay, because I think that as we talk about how to defend intelligent design, you are going to get a good sense of what ID is and exactly what it claims. How many of you have ever had this happen to you? You make a very careful, compelling, well-documented case for intelligent design, perhaps based upon the presence of information in DNA or protein complexity, molecular machines, maybe based upon the fine-tuning of the universe. But then you're immediately told this, okay? ID is not science but religion, and you're not allowed to claim otherwise because a federal judge said so. Have you guys ever had this happen to you? I've had this happen to me many times. They don't even address the arguments that you're making. They don't even try to respond to your scientific point. So is ID really just religion and not science? And what did that federal judge say? And was he right? I like to start off my talk sometimes with a survey of what do you think intelligent design is. I'm going to give you two choices. I want to get you to give me your honest answer of how would you define intelligent design. Would you say that A, life is so complex that it couldn't have evolved, therefore it was designed by a supernatural being? Or would you say B, many features of nature are best explained by an intelligent cause, because in our experience, intelligence is the cause of their informational properties. If you said A, you're wrong, but don't feel too bad, because it just means that you read news articles, because this is sort of the definition of intelligent design that gets recycled in news story after news story after news story. So what is wrong with definition A, and why don't we like to use definition A? Well, there's a couple of things that I would say are wrong with definition A. First of all, it frames intelligent design as if it is simply a negative argument against evolution. Now, don't get me wrong. I'm a major skeptic of Darwinian evolution, and I think there's a lot of problems with it. And intelligent design certainly is critical of many aspects of Darwinian evolution. But ID is not simply or strictly a negative argument against evolution. It's also a positive argument. So it doesn't just say life is so complex that it couldn't have evolved, therefore it was designed, okay? It's also a positive argument that's based upon finding in nature the kind of information and complexity which in our experience comes only from intelligence. We're going to talk about that more as this presentation goes on. The other problem with definition A is that it gets into sort of the nature and the identity of the designer. ID as a scientific theory does not try to address religious questions about who the designer is. So I personally am a Christian, and I'm very open about this, whether I'm talking to probably a largely Christian audience like this one, or when I speak to secular audiences. But I also make it clear that my view that the God of the Bible is the designer, that's my personal religious belief. It's not necessarily a conclusion of intelligent design. And intelligent design as a science science does not try to address those religious questions about who the designer is. And in fact, within the ID community, I have colleagues who come from non-Christian backgrounds. I have friends in the ID community who are Jewish, who are Muslims, who are even agnostics, who aren't sure who the designer is. Well, we all share as a conviction that the scientific evidence shows that there is real evidence for intelligent design in nature. So this is how I would define ID. Many features of nature are best explained by an intelligent cause, because in our experience, intelligence is the cause of their informational properties. We're going to talk more about this, but it basically comes down to finding in nature the kind of information and complexity which in our experience always comes from intelligence. And so when people tell me that ID isn't science, one of the first things I like to remind them of is that ID reasoning is already being used in science. For example, archaeology. If you're hiking and you find some kind of an artifact and you want to ask the question, was this stone object, did it come into the shape through intelligent causes? Was it intelligently designed? Or is it just a natural object? Is it just a normal everyday rock that has no intelligent design? So if you find, of course, an arrowhead, or you go to Easter Island and you find these strange stone heads, you're going to look at those and you're going to say, you know what? These objects did not simply come about by natural causes. They were carved into this shape for a purpose. And so archaeologists will regularly use ID reasoning whenever they conclude that an artifact was designed. Another field of science that uses ID reasoning is forensic science. Every single time our legal system convicts somebody of a crime, we are literally making a design inference. We are detecting design. We're saying that this intelligent agent is responsible for this particular fact pattern, and we're convicting them of a crime. So these are very, very important questions that our legal system has to address. So we are very, very good in our society already at making design inferences. So what the theory of ID says is, if we can detect design in forensic science, archaeology, and these other fields, why not in biology, where all of life is fundamentally based upon a language-based code? Can we also detect design in biology? Another field that uses ID reasoning is called the search for extraterrestrial intelligence. Well, basically, in SETI, they have an array of radio telescopes, and it's scanning the skies for radio signals, hoping to find one that actually comes from some kind of an alien civilization trying to get our attention. And now, of course, they have not discovered any aliens yet. But what's important is that they are trying to detect design in radio signals that are coming from outer space. So when people tell me that ID isn't science, after I remind them that there is already a variety of scientific fields that use ID reasoning, the next thing I do is I explain to them how we use the scientific method to detect intelligent design. And if you think back to maybe your high school biology class, the scientific method is often described as a four-step process of observation, hypothesis, experiment, and conclusion. And it turns out that ID uses this exact method to make its claims. So ID begins with observations that intelligent agents produce high levels of what we call complex and specified information. Don't worry if this term is unfamiliar to you. I'm going to define it in just a moment here. But the bottom line is that there's certain types of information and complexity which always comes from intelligence, and that allows us to identify when something was designed. This is a quote from a famous information theorist named Henry Quasler. He says, "The creation of new information is habitually associated with conscious activity. When we see new information coming into existence, it almost always comes from intelligence." And this is another very nice quote. This is from Stephen Meyer, and this is what he says. He says, "Our experience-based knowledge of information flow confirms that systems with large amounts of specified complexity, especially codes and languages, invariably originate from an intelligent source, from a mind or a personal agent." So what's he saying here? Again, he's saying that there are certain types of information. He uses the term specified complexity. That's basically a synonym for complex and specified information. But what he's saying is that when we see this kind of information, in our experience, it always traces back to a mind or an intelligent being. And he gives two examples of this: codes and languages. And we're going to talk about this in just a minute, that at the very heart of life is a language-based code. So we detect design by finding complex and specified information, also called CSI, because in our experience, CSI always comes from intelligence. So let's define CSI and explain what it is. When we say that something is complex, roughly speaking, that means that it is unlikely. Something that would be a sort of potentially a random or unlikely event would be this sequence of zeros and ones that we see in this hypothetical microorganism that we're looking at under the microscope here. 0, 1, 0, 0, 0, 1, 0, 0, 1, 1, et cetera, et cetera. Now, the question then becomes, is unlikelihood alone enough to detect design? And the answer is no. Unlikely things happen all the time, and we don't necessarily detect design. The likelihood of every one of you sitting in this exact spot in this room in each chair is probably very unlikely, but nobody's going to say that this was exactly pre-planned. Or let's say that you play poker. If I were to deal each of you out a 5-card hand of poker, the likelihood of you each getting the exact hand of cards that you get is very, very low. But even if you get a very good hand, like a royal flush or a straight, the likelihood of you getting that hand of cards is very, very low. But let's say that then I deal you each out a hand of cards, and every one of you gets a royal flush. And then I deal you out a hand of cards again, and you each get a royal flush. Now you're going to say, you know what? I think there's something special going on. I think that the deck was stacked. So we need something more than just unlikelihood to detect design. We also have to be able to say that what we're looking at is specified, meaning that it matches some independent pattern. In fact, it turns out that this sequence of zeros and ones here, it's not just a random sequence of zeros and ones. It's actually computer code. It's binary code, codes for the ASCII characters that spell out this sentence in the English language. This is, of course, a very famous quote from Richard Dawkins. And he said, "Biology is the study of complicated things that give the appearance of having been designed for a purpose." Now, Dawkins, of course, believes that natural selection did the designing, that things just look designed. But what we would say in the ID movement is that the reason that many features of biology look designed is because they really were designed. It's not just apparent design, it's real design. In any case, the point is that this is not just a random sequence of zeros and ones, it's actually computer code that spells out a sentence in the English language. That means that it matches a recognizable pattern. And we have something that is both unlikely and it matches a pattern. Then we have complex and specified information, and we can detect design. Let me give you guys maybe a more practical example of this to help you understand. This is Johan. Johan is going on a tour of mountains of the United States. And so first, Johan comes across this mountain. And he says, you know what? This mountain has a very unlikely shape. The odds that there's going to be a ridge here, and a ridge here, and a gully there, et cetera, et cetera. The odds of this mountain having the exact shape that it does is very, very low. However, there's no special pattern in this mountain. This looks like a normally shaped mountain. So yes, it has a shape that is unlikely or complex, but it's not specified to match any pattern. So he's not going to detect design. He's going to say, this mountain's shape is natural, it was not designed. Next, of course, Johan goes to this mountain, and he says, okay, this mountain also has a very unlikely shape. It's complex, but now there's something else going on. It also matches a known pattern, namely the faces of 4 famous presidents. So we have a specific pattern that is also complex, then we can detect design. We just use complex and specified information to detect design. So again, remember, we started with this observation that intelligent agents will produce high levels of complex and specified information. So because of this observation, we can now make a hypothesis. And the hypothesis says that if a natural object was designed, then it will contain high levels of CSI. This is the next step in the scientific method. And we can then perform a variety of different kinds of experimental tests to determine whether or not natural structures contain high CSI. And one type of experiment we can do to test for high CSI is something called a mutational sensitivity test. We can determine basically whether or not the sequence of amino acids in a protein is very, very precisely ordered in order to allow that protein to function. What is a protein? Proteins are basically the workhorse molecules in your cells and in your body. They perform many enzymatic functions, and they also form many of the structures in your cells. And a protein is basically a very long chain of amino acids that then folds up into a very particular shape in order to perform some very particular function. And the question that we're going to ask, and this was asked by my colleague, Dr. Douglas Axe, is how precisely ordered does that sequence of amino acids have to be in a protein in order for it to be able to perform its function? In other words, he's saying how common or rare are functional sequences of amino acids in order to yield a functional protein. And what Dr. Axe basically did was he took a protein called beta-lactamase, and as he mutated it, basically moving along different sequences through what we call sequence space, he found that only at very, very precise sequences of amino acids will that enzyme actually give you high level of activity where it's functional. So what he basically found is that you have to have a very, very precisely ordered sequence of amino acids in order for the protein to function. In fact, he found that the likelihood of a random chance sequence of amino acids giving you a functional protein like beta-lactamase is 1 in 10 to the 77th. What this means is that proteins are high CSI features in biology. We have these very unlikely sequences of amino acids that have to be exactly right in order for proteins to be able to function. Now, the question then becomes, well, is that possible for something that is this unlikely to evolve? Well, let me give you a picture of just how unlikely it would be for something like this to evolve. There have only been about 10 to the 40th organisms that have lived over the entire history of life on Earth. So that means that if we were to give this sort of extremely generous assumption to evolution, that every single organism that ever lived was sort of magically gifted in 150 randomly ordered sequence of amino acids, hoping that you would get a functional protein like this, you would still be short by about 10 to the 37th trials just to get a single functional protein like beta-lactamase. What this means is that there are vastly insufficient probabilistic resources across Earth's entire history to produce the kinds of complex and specified information that we observe in proteins. Okay, so conclusion. Because X exhibits high levels of CSI, a quality known to be produced only by intelligent design, we conclude that this structure was intelligently designed. Again, to recap, how does ID use the scientific method? We start with the observation that intelligence is the cause of high CSI. We then predict or make a hypothesis that life will contain high levels of complex and specified information. We can then experimentally test for high CSI through things like mutational sensitivity tests in protein, and we uncover astronomical CSI in biological systems, and we conclude that life was designed. So ID is using the scientific method here to make its claims. And the basic logic is basically like this. First, an ID scientist finds that mind is the cause of certain types of information, or CSI as we call it. Then she goes out into the natural world and finds that same kind of information in nature and infers that a mind was at work in causing that type of information. So this is what I like to say. You could disagree with the conclusions of ID, but you can't reasonably claim that the argument I'm making today is based upon religion or faith or divine revelation, okay? Even if you disagree with the conclusions, I haven't been invoking the Bible or faith or scripture or any of that. I made an argument based upon science. So when somebody comes to you and says, ID is not science, you can explain to them how ID uses the scientific method to make its claims. Okay, so what about that federal court ruling? Because the critic is often going to tell you, well, a federal judge, this happened in a court case called the Kitzmiller versus Dover case. It happened in 2005. It was from the lowest level of the federal courts. So it's not the Supreme Court. This is not binding precedent all over the country. It's only in really the lowest level of the federal courts, and it's only binding the Middle District of Pennsylvania. But it is true that one federal judge did rule that ID is religion and not science. So this is what I like to say to folks. Don't think that federal judges are inerrant. Just because a federal judge said it doesn't mean it's true. But we have to be willing to think critically. In fact, if you spend one single day in law school, I did go to law school, I'm an attorney, you spend a single day in law school, you'll learn that law professors make careers out of telling you what federal judges got wrong, okay? So federal judges get things wrong all the time. And in this case, the court got a lot of things wrong. We could spend hours going over what the court got wrong, but let me give you a little summary of what the court got wrong in this case. First of all, the judge misdefined intelligent design. He didn't even define intelligent design properly. He wrongly claimed that it requires supernatural creation, which was a position that ID proponents refuted during testimony during the trial. He also ignored this positive argument for design that we just talked about, using information to detect design, and he falsely claimed that ID makes its case strictly by arguing against evolution. So he's basically misdefined and misrepresented what intelligent design is. He also wrongly claimed that ID was refuted in his court when in reality he was presented with credible scientific witnesses and publications on both sides of the debate showing evidence of a scientific controversy, not that one side had refuted the other. He used very dubious philosophy of science, where he took the level of support for a theory in the scientific community as evidence for whether or not it's scientific. If you always said that if the majority of the scientific community believes something, and in this case, yeah, it's true, the majority of scientists probably do disagree with ID, that doesn't mean it's therefore wrong. If we took a philosophy of science like that, then science would never be able to progress. Because every new scientific theory starts off as a minority scientific view before it then takes over and we have a scientific revolution. We have to allow minority scientific views to be heard. We can't just have courts ruling that they are not science. He also sort of just denied the existence of peer-reviewed pro-ID scientific papers that were documented before the court, and the court just basically ignored them and pretended that they didn't exist. He explicitly just denied them. And the court also adopted what I would say is an unfair standard of legal analysis, where religious implications, beliefs, and motives and affiliations, they always counted against intelligent design, but never against Darwinism. So it was very, very sort of one-sided, biased way of approaching this issue. But not everybody agreed with this court ruling. This is really important. There's a leading anti-ID legal scholar named Jay Wexler. He called this ruling that ID is not science, quote, unnecessary, unconvincing, not particularly suited to the judicial role, and perhaps even dangerous both to science and freedom of religion. So I would say that federal courts cannot settle scientific debates. The day after the Dover ruling, ourselves were still full of language-based digital codes and miniature factories that produce micromolecular machines, and the universe remained exquisitely fine-tuned to sustain life. So this debate, it can be settled only by the evidence, not by legal declarations. So don't let anybody tell you that this court case somehow refuted intelligent design. You've got to think more critically than that. I know you guys would do that, but don't let the critics get away with that. So let's talk a little bit more about the evidence. I want to now go into some scientific objections to intelligent design. One of the most common objections that we hear when we talk about intelligent design is something called co-option. So we have in biology these complex molecular machines that require all of their parts to be present in order for them to be able to function. We call these irreducibly complex. They're irreducibly complex because if you try to reduce their complexity, they won't work. They won't function. And they challenge a Darwinian explanation. Darwinian evolution requires a structure to remain functional at every little small step of its evolution. But these molecular machines that we have in our bodies, they require lots of parts to be present before they give you any function. And they can't evolve one small little step at a time. It's kind of like an all or nothing game. Either all the parts are there and they function and they give you an advantage, or it's missing a part and it doesn't give you any function. So that's basically a major challenge to Darwinian evolution, and it's good evidence for intelligent design. So one of the criticisms that we hear, one of the responses that we hear, is that you can evolve these complex molecular machines through something called co-option. Basically what this objection says is that as you are evolving these molecular machines, you can borrow parts from other places in the cell and somehow kind of magically retool those proteins to come together and spontaneously form a totally new system. So this is the way that I would describe co-option. It's kind of like saying you start off with a hammer, and that hammer somehow gets co-opted to turn into a key, and then you start off with this sort of this clamp or this trap, and this clamp or this trap suddenly gets co-opted to turn into a lock. And then somehow that lock and that key are able to work together to open one another, okay? It's kind of like you're starting off with one type of tool, turning it into another, and then suddenly, after you've done this a bunch of different times, those parts can interact with each other to perform some complex function. And I want to make some responses to co-option very quickly. Well, first of all, if you're going to borrow a part, you have to have someplace to borrow it from. We have no idea where many of the parts that we find in these molecular machines could be borrowed from because they're unique. They don't look like anything else in biology. When you do get an argument that they could be borrowed, the evidence basically comes down to this. They will say that this protein in this molecular machine has an amino acid sequence that is kind of similar to another protein, okay? It's not identical, it just has some degree of similarity. Well, sequence similarity, what we often call homology, does not demonstrate a stepwise evolutionary pathway, okay? Because these parts are very different from one another. You cannot just, make one or two little changes to a protein to get it to suddenly then perform a totally different function in the cell. Remember that study we just talked about, that only 1 in every 10 to the 77th sequences would give you this functional beta-lactamase enzyme. Well, it's like that with a lot of proteins. Functional protein sequences are very, very rare. And it's very unlikely that you're going to be able to just, have a couple of changes to a protein to then be able to radically change it to perform some totally different function. So what this means is that these parts in the cell are not necessarily easily interchangeable. Many changes have to happen, many mutations have to occur, and this is very unlikely to happen by Darwinian evolution. Another thing that proponents of co-option often don't talk about is the assembly instructions. You see, it's not just enough to have the parts to build a machine. I could put all the parts necessary for a computer in a box, right? I could even shake it up or, shake it for 1,000,000 years. You're never going to get a computer. You have to be able to properly assemble those parts into a machine. And the same is true with these molecular machines in our bodies. You have to be able to explain the assembly instructions for how these molecular machines assemble. And proponents of co-option never talk about the assembly instructions for these molecular machines. But here's what I think would be probably the most fundamental problem, is that co-option requires great leaps of complexity, okay? This is kind of, again, another example of what co-option would be like. It would be like saying, okay, I've got a laptop here, and my laptop has a power cord. Actually, I didn't plug the laptop in, but I've got the power cord right here, okay? So if I were to take this power cord and I were to plug it in and I were to say, okay, because this power cord could also be used to power my toaster, therefore I can explain how my laptop can evolve. No. Maybe I can explain how one part of the laptop came to be. Maybe I can explain how the power cord evolved. But there's a lot more complexity going on in the laptop than just the power cord, right? There's a lot more that you have to explain. And so co-option almost always involves great leaps of complexity. One of my colleagues in the ID movement has said it's kind of like finding the Hawaiian Islands and then claiming that you found a way to walk from Los Angeles to Tokyo, okay? That's just not a very good evolutionary explanation. You need a lot more detail to provide a proper evolutionary explanation for how these complex systems evolve. So co-option requires great leaps of complexity. It also faces a catch-22, and that is that the more similar the precursor is in these co-option explanations to the final system, the more teleological the explanation begins to sound, okay? So you start to actually have these co-option explanations that sound very goal-directed, very purpose-driven, very teleological. And so I don't think that they're very good. Finally, where in our experience do things like co-option happen? Well, I love this quote. This is by two of my colleagues, William Dembski and Jonathan Witt. They say, what is the one thing in our experience that co-opts irreducibly complex machines and uses their parts to build a new and more intricate machine? Intelligent agents. So whenever we see co-option going on in the real world, it always involves intelligent design. Let's talk about another very common objection to intelligent design. This is called junk DNA. This is an objection that I've been hearing for many years. I've been around the ID debate for a couple of decades, and very frequently I've heard people say, you can't claim that our cells are designed because the vast majority of our genome is actually genetic junk. It's not doing anything. It's just there because of random evolutionary mutations filling up our genomes with evolutionary debris and garbage, and no designer would ever put this kind of random, useless genetic junk in our genomes. This is evidence against intelligent design. And in fact, many ID critics, Ken Miller, Francis Collins, Richard Dawkins, have all argued that the presence of junk DNA in our cells refutes intelligent design. However, the good news for ID proponents is that the evidence for junk DNA is actually very, very weak. And in fact, the evidence has shown that most of the DNA in our bodies is not, in fact, junk. There was a major study that came out in 2012 called ENCODE. And what they did was they studied this DNA in our cells that is not coding for proteins. And what they found is that over 80% of our genome shows evidence of biochemical functionality. So the evidence in biology right now is strongly trending in the direction that our genome is not full of junk DNA and that our DNA is actually functional. You might say, well, why only 80%? Does that mean that 20% of our genome is actually, in fact, junk DNA? Well, no. When they did the ENCODE project, they only studied about 150 cell types in the human body. And we have thousands of different cell types. And one of the lead ENCODE researchers predicted that as they study more and more cell types, they're going to find that every single nucleotide base in our DNA, in fact, is associated with a function. Consider this article that came out in the journal Science. It said that the ENCODE project wrote the eulogy for junk DNA. And it said that 30 research papers, including 6 in Nature and additional papers in Science, sound the death knell for the idea that our DNA is mostly littered with useless bases. In fact, there was a paper that came out just a couple years ago that said the days of junk DNA are over. So this is a very popular argument. In fact, we still hear evolutionists making this argument. I see these folks kind of like, at the end of World War II, you have those holdouts who are still living in caves and would acknowledge that the war was over. I think this debate is over, but some evolutionists are so committed to junk DNA, they just don't want to see it. Okay, finally, dealing with new objections. You might hear an objection you never heard before, and I want to encourage you guys, if you don't know the answer to an objection, it's always okay to say, you know what? I don't know the answer. Let me research that and get back to you. Thank you guys very much.
That was Dr. Casey Luskin speaking recently on how to defend intelligent design. I hope you found it as helpful as I did. Even if we've been around the arguments of intelligent design for years, as I have, Dr. Luskin provided some great reminders of just how compelling the case for design in biology really is. Now, this is just a taste. For more videos, articles, and other resources on intelligent design that you can enjoy yourself as well as share with others, check out intelligentdesign.org. That's intelligentdesign.org. Thanks for listening today. We created this podcast to help you learn more about the evidence for intelligent design and the debate over evolution. If you're enjoying our content, leave a review at Apple Podcasts and share an episode with a friend. Thanks for your support. For ID the Future, I'm Andrew McDermott. Thanks for listening.
Visit us at idthefuture.com and intelligentdesign.org. This program is copyright Discovery Institute and recorded by its Center for Science and Culture.